I'm Devlin Duldulao. I came from Philippines, from Manila, where I was born. Moved here 5 years ago. And what else? Working for Inmera, it's a consultancy. And yeah, Microsoft MVP. So during pandemic, I couldn't go back to Manila. So yeah, it's like lockdown, right? So I decided to write a book, ASP.NET Core. That's my first book, followed by two who I co-written. I wouldn't suggest, I wouldn't advise anyone to write book because it's time-consuming and you're not gonna get rich. Anyway, so agenda for the day, exposing microservices, ways, retry policy. What is retry policy? Circuit breaker pattern. Then probably like demo of retry policy and circuit breaker pattern. I'm gonna use ASP.NET Core, 2 projects, and then I'm gonna use the .NET 9 release candidate. So normally, a retry in mobile apps, it helps the user experience improve. Like for example, the user wouldn't have to click the button repeatedly. It's normal, right? That every now and then your application might not or may not be sending proper objects or getting errors in the network. There's so many reasons why. So yeah, it's just normal for application. Could be like web app or IoT or a mobile app. So why do web services or why backend would fail the request? Your web service request travels over combination of let's say, unreliable communication channels, moving to different computers and causing even more complex and unreliable software to execute. So it could be infrastructure upgrade, could be like faulty network connection, or null reference on someone else's code, server unavailable, bad deployment, it happens, and could be else. So a retry policy can retry again failed requests with just few lines of code, depending on what you're using. There's so many ways to implement this, but that's only the start of what retry policy can do. I'll explain more later. So going back to not sending properly, right? Then this is actually what a retry policy will do. As you can see, a mobile app, this could be like a client app. And the client app is the one who's just, the one repeating the request, not the user itself. Then eventually, I get it, done, and then returning it to the user. So that's where the user experience or the improvement of the user experience comes from, because of this retry that piece of code does the retry automatically rather than the user. So, but I'm not going to use Xamarin or Maui here or any client application. We're going to use this sample in basis of microservices. You can use this also in server-to-server communication, by the way. And more on the downstream microservice failure, aka dependency failure. Okay, just to give you an overview, microservices are usually built to be called by applications or used by external consumers, right? And the way it's done will determine how the software should be developed and how it can evolve. There are 3 main ways how you can expose your microservices, outside. The first method is is to expose all microservices directly. This is not recommended. It's a bad idea to do this. The second one is to build special microservices called facades. Like for example, a BFF pattern, like a back-end for front-end pattern. It's an example of that, representing an entry point into your system. And then the third method is to use an external software called API gateway, which will provide those external entry points. So just to give you an example how it looks like, there are cloud-specific implementations of API gateways, available in Microsoft Azure or AWS Cloud. You can have free and simple solutions like Kong or Nginx Plus, or complex and feature-rich API management platforms will provide you external interfaces and sometimes create website documentation right away when you use it, or SDK sometimes. So it depends. What are you targeting to use? So pros here. So API gateways offer several advantages, similar to facades, including protecting your internal design and simplifying system evolution with a single entry point. So they excel at, number one here is security. So they excel at managing cross-cutting concerns like security. That's number one why we choose an API gateway, because security is hard, by the way. Logging, right? Throttling and tracing. Cloud-native solutions come pre-integrated with essential services like, for example, identity management to enhance security. And again, they have their own team in for example, a department for security rather than doing it by yourself. So API management platforms also provide, let's say, additional features such as generating client websites, which is I mentioned earlier, right? And of course, there are like drawbacks to consider. So API gateways are new technologies that require learning. So you have to give time to understand how it's being used, which could become a challenge, especially if relying on vendors that may go out of business. For example, a startup API gateway vendor. Sometimes it's like, oh, bankrupt, then you're done. So some gateways have limited functionality, making non-standard tasks like handling asynchronous messages difficult. What else? Managing large APIs, with gateways it's also challenging, requiring new development, versioning and deploying practices which differ from standard microservice processes. This is just an interface, for example, of API management in Microsoft Azure. So as you can see, there are tools that you can use straight away. For example, you can just expose your open API, and then the API management will consume it, giving you this mapping of endpoints. So basically, it's very easy. It auto-generates things, which it's cumbersome to do it by yourself, time-consuming. That's why they have this to automate things for you. And then the retry here comes in, for example, policies. You can be like configuring inbound processing, outbound processing, or whatever you want to set there as like a configuration. So this is out of the box that you can just click and then boom, you have to just edit some XML. Again, time saving if you're using this with a little, just paying the service of Microsoft. Or you can do it by yourself. So before we move to a demo, let's just read some of the terminologies that we're going to use in resiliency. So for example, the retry policies are nothing but keep you retrying. So you make a request to another service or maybe an external API or service to get data. Then you can choose what kind of approach for waiting time. For example, constant waiting time to send the rest of the requests, or exponentially increasing by, let's say, 2, and then or specified list like this specific time. Circuit breaker policy. So this is especially important when you're sending lots of concurrent requests. And this is something that you shouldn't forget when you implementing retry policy. You can quickly run into big problems such as port exhaustion. And if you're using HTTP client, and let's say you have 100,000 of users at that specific given time, or 1 million users, and then all the application is sending multiple requests because they are retrying, right? So you need to stop that retry, or like, hey, there's like 1 million users trying to retry times 5 in over of this every 2 seconds. Now you're being DDoS because it automatically, right? The application itself will just send retry. So if you don't have any mechanism of stopping this retrying, you ended up like, oh, I just DDoS my own infrastructure. So another terminology, this is more on the electrical engineering background. So close in electrical circuits, when a circuit breaker is closed, indicates that electric current is passing or flowing. In the resilience pattern, it means that you are passing requests, or the request is flowing. What about open? So open in this state, so this is, by the way, a state in your server, and it's being handled by a library or by yourself. The circuit does not pass the request to the destination, only return the requester that the service is out, unavailable, so it will just stop it from the gateway or from the facade API. So it will not flow to the rest of the, and it's not gonna flow to your controller in your, for example, in dotnet, you have your controllers. If you put a breakpoint there, it will just like, it will not get triggered. So open meaning not available for any request. So half open, so this is a check state. So after reaching the time in the open state, then the system will just allow 1 or 2 requests, depending on your configuration, just to see if, let's say, AWS is already up. Because sometimes they're down for 3 hours, right? Or a Microsoft data center in, let's say, in Singapore is down for 2 hours. So half open meaning, okay, let's just let us pass maybe 5 requests and see if it's gonna go. It's going to return 200 okay, meaning the data center is okay now or stable. So we can now let again 1 million users pass the request. What else? Infrastructure-based resiliency. So a sample of this is a cloud infrastructure resiliency. API management, Azure, right? This is the best example that I can give you, or from other cloud services. So it looks like this. You have this XML which you can configure, which is I mentioned earlier, and you can set how many count, interval, etc. So this is now your retry, and then you can also set the circuit breaker here, right? So that's for the cloud infrastructure. What about your own implementation? That's what we call code-based resiliency. Now, you're not relying in API management or API gateway. You can implement this in, for example, in your facade API, right? API gateway. So, yeah, we can do demo here. I'm gonna use Poly. So, and we're not gonna use the HTTP Poly, which has been just deprecated, maybe 2 months ago. We're gonna use the HTTP resilience. So it's part. So this is not. You're not gonna directly use the Poly library. These Microsoft extensions already using it under the hood. So I wouldn't recommend. There's a lot of this HTTP Poly blogs and videos still out there, but I don't recommend it anymore. There's a few now HTTP resilience. implementation, so just be careful. But they're still okay, the poly, but it's not gonna be supported anymore in the future. Wait, that's demo, okay? Okay. So 2 projects here. So this is my facade, as you can see. I think you can see here. And I have this another service, an upstream. So here I'm just going to create a random number. So if I send a number, let's say integer 50, there's like 50-50 chance of it's gonna fail. If I use, let's say 99 or 100, it's like most likely it's gonna get an HTTP 200 okay, right? Or if I use a number lesser than like 30, it will like most likely gonna fail. So there's no resilience here because this is the upstream service. The polish would be in the facade again. So again, HTTP resilience library, you should install it. And then you can add it here in your HTTP client. But it will not appear here, the resilience, because add HTTP client it's not specific. This will apply to all the controllers. You don't want to do that, right? You need to pass, this is overloading, you need to pass a name, and the name is a logical separator for controllers. Why do I need this logical? Because this is better because you can pick which controller you will just gonna use some policies or circuit breaker or retry. You don't want to use this accidentally in authentication. What if someone's trying to log in and it's failing because the username or the email and the password doesn't match, and now you're automatically resending the request. Okay, send again, trying to retry this. Doesn't match password. It doesn't make sense to put it in authentication. So that's why by default you cannot do that. So you have to write something here that say to do API, and then now you can use this standard, and then you can configure this, of course. But if you go there, there's like a standard like a set of values already inside of this. Why it's not opening here, but it's okay. Like default values that you can use. But this is not what you're gonna do in real world, like using the default values of this standard resiliency. You're not gonna do that. Instead, and this is also not real world doing it of dependency injection, putting it here. You're gonna use, of course, iService collection. So you can do this. Again, being specific which endpoint will have this resiliency. Now we're adding this add standard resilience handler, and now you can now configure it. A cleaner way, I just separated it here, but we're gonna go there later. So as you can see, I'm adding retry here. I'm adding circuit breaker pattern, and I'm also adding some timeouts. And then this is now reusable, this resilience policy register, because I can add more or create more dependency injection here, and then just include it in my program.cs. So what's here? So in HTTP retry strategy options, you have this max retry attempts. By default, I thought it's 3. Yeah, I think it's 3. And Now you can configure it. There's some default values here, but of course the best practice is to strategize how many retry attempts you want to use or want to do, depending on the number of your users. Delay also, here, this is the initial delay before the first retry attempt, delay of 2 seconds, and then I'm gonna use this exponential back off, meaning it's just gonna multiply, 2 seconds, and then the second attempt would be like 4 seconds, and the third attempt will be 8 seconds, and so on. And you also need to use this jitter, it's a best practice when you're using this back off to help it, prevent retry storms by randomizing retry intervals. And then you have a hook here that you can use to log something. But right now, I'm not logging anything. I'm just saying retry attempt, and then I'm just getting the attempt numbers of how many this already. And then you need to return this completed task. And then what else you'd want to throw? Is it 500, or depending on what HTTP status? You can be very granular here to be picky which status code you just want to handle or to retry, right? And that's for the retry strategy. And for the circuit breaker, we have this sampling duration. So this is the time window over which failures rates are evaluated. And then the longer sampling duration provides more accurate minimum throughput, break duration. This is very important to configure. It's up to you whether it's 6 seconds. So remember that the state, the open state, meaning it's not gonna let any HTTP request come into your application, right? So this break duration tells you 60 seconds. It will just wait for a whole minute before it will start to reopen again, not open, but to allow again the request. You could put here 30 seconds, 60 seconds, depending, also depending on the data center you're using, if it's often not available, so maybe you can, increase it more. But anyways, on open, so if you want to use a hook, when the state is open, you can use it here on open. And I just put it here, circuit breaker is open. For the close, there's also a hook that you can use, log or whatever. And then again, should handle what specific status code are you interested in. So very granular. So after doing that, so we can, as you can see again, add HTTP client, return services. Now we can do that in the controller, which is, you need to, again, use this HTTP client factory to create a client with this logical name, and then that will apply the retry policy here, as you can see. Now my demo would be, I have another controller here, it's like for events, and the name is different. I didn't create additional ASP.NET Core project, a lot of work. One is okay, and then I just created additional controller here. Just imagine there's like 2 upstream dependencies here, or services. So let's run this. I'm using Rider, and that would run my to-do. Now I'm gonna run the facade. And then we have to be watching here because there's some logs here, right? So let's try first the to-do, that, how it behaves, so you can see. Guess this is good. So 99 would give us basically perfect. So, yeah, this is the result. Bruno Mars is live in Oslo. If you put it 1 or 10, 10%, okay, 90% is gonna fail. It failed, right? So that's the upstream. Now let's go to facade. So meaning it's working, right? Let's go to facade. Which one here first? The events. The events doesn't have the retry, right? So if I'm gonna put here 20, which is 20% chance of making it true. It's throwing an error. No retry happening. No retry, because you can see the loading just flicker. So meaning it's not retrying. So imagine this is an Angular application or React or a mobile application, right? So the user will just bam, 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 right? That's what's gonna happen, especially if the user cannot wait. I'm gonna send this is, it's not sending, why? Right? Yeah, just like you're missing your girlfriend or, just like text. So let's go to the other one, which is the to-dos. Now, the user, you're gonna use this, and then trying to send, 33% chance of making it true. Oh, let's lower this. It went through right away, or maybe 10. So you can see that it's not gonna work. 10% chance successful. What? You're kidding me? It's like a winning lottery. Oh no. Okay, 1. So you can see loading in behind the scene. So you can see it's throwing error, but you don't have to, the user doesn't have to send requests, right? And then failure, right? So that's 1. Let's send another one, just 1. This will, again, retry attempt. 2, it's sending. This is facade. Let's go in the other one. Error. This should trigger the circuit breaker, right? So like, oh, hold on. This is not just a glitch in the network. AWS is down again for probably 8 hours, so you should, stop sending me requests. So that's what's happening. So if you send again, you can see here, sending, facade failure, do again. Retry attempt. Okay, so the state now is open, meaning if I click this, it will just like boom, no more. See? Even if you put here a breakpoint here, it's not gonna go there. Oh wait, let's go there. But yeah. Wait. But it's gonna halt it to go through the other API. Oops. Hold on. Yeah. And then you have to wait for, again, 60 seconds, right? And then I think it's already 60 seconds. Nope. Okay, so 60 seconds. Let's see if it's gonna do a close, meaning it's going to allow now. Let's make this, like say 30. So you can see here the logical why it's very important to know which controller or router you would just apply the retry policy. Otherwise, for example, the authentication endpoint or whatever, or it could be anything. It does, it doesn't have to be just the auth API endpoint. It depends on the situation or the problem you're solving. if it needs to be, if it's a critical, for a user, critical functionality that, it will help the user's user experience, then why not use this retry policy rather than, letting the user click it. So, so it's open. I think let's put it in 90. So it's still open, meaning it's still not letting it flow. It gets retriggered again another 60 seconds if it's still not, returning HTTP request 200 OK, because I think I put it in the like 20 and it failed again. So in writing this resiliency pattern, I would encourage you to create your like a DI or service to just inject it. It's easier. It's gonna be reusable. Yeah, it's very simple, as you can see, right? Let's do it again if it's already. Okay, so it's flowing now, right? So this is implementing retry policy at your own, without using an API gateway. Okay, now we can back to a demo slides. So other usage scenarios of a retry policy, reading, writing to file system, using databases, or reading, writing to message queue. And to summarize a retry policy, the request is retried after a short wait if an error response is received. And then circuit breaker policy gives the target service a break, after a repeated number of failures. And then resiliency is about recovering from failure, and then infrastructure-based, like API management services or code-based, what you just saw here, using third-party libraries. Highly recommend than writing in your own. Just use Poly. Resources, go to PolyDocs. You can go there, or this bunch of blogs about Poly, the polyproject.org. And then the demo code is just here. You can just take a look at it. And yeah, to syntax.